Hello everyone, welcome back to Math 143, Finite Mathematics. Today we will learn the intersection of straight lines, section 1.4. By the end of this lecture, you should be able to find the intersection point of two lines, solve systems of linear equations, determine break-even points in business applications, find equilibrium points in supply and demand models. So before then, let's quick review what we learned last time. So in section 1.3, we introduced linear functions and mathematical models. And also we discussed the cost function, revenue function, and profit function. Also, demand and supply equations. Today, we will combine those ideas and see how the intersection of two lines help us solve real business and economic problems. Okay, let's start. Suppose we have two straight lines. If the two lines crosses each other, that means they meet at exactly one point called the point of intersection. Since that point lies on both lines, its coordinates satisfy both equations simultaneously. Therefore, finding the intersection point means solving a system of two linear equations. Let's say we have two straight lines L1 and L2 with the equations m1x plus b1, m2, let's see, y equals m1x plus b1 and y equals m2x plus b2. Two straight lines L1 and L2. So if these two lines crosses each other, if these two lines, let's say y equals m1x plus, let's say two lines, this is L1, this is L2. The intersection point, the point of intersection. They meet at exactly one point. This is called the point of intersection. Also, the pair of x and y. Let's call that point is P naught, x naught, y naught. So both x naught and y naught satisfied and lies on both lines. So that means the finding the intersection point means solving a system of two linear equations like L1 and L2. Okay, let's move forward. Let's get the numerical example, like work through an example must be the easiest way to get the basic idea behind the intersection points. So finding the point of intersection. Here are two lines, y equals 2x plus 1, y equals negative x plus 7. So you can see that we have y equals, both left sides are equal. Then let's talk through each step. Since both expressions equal y, then we set them equal, right? 2x plus 1 equals negative x plus 7. Then we can solve this for x since we have only variable x here. 3x equals 6, x equals 2. Then substitute that x equals 2 into the either of 1 or 2. y equals 2 times 2 plus 1. 4 plus 1, 5. Therefore, the point of intersection should be x equals 2, y equals 5. The point of intersection. Okay, so let's discuss one more. Then let's say y equals 3x plus 6 and y equals 2x plus 4. Then take both equal. 3x plus 6 equals 2x plus 4. Then x equals -2 by substituting 3 times -2 plus 6. Y equals -6 plus 6, y equals 0. The point of intersection, y equals -2, x equals -2, y equals 0. Okay. Then let's go for the real world example, real world application. So recall the cost function, revenue function and profit function. The cost function C of x plus f r of x, and the profit function, the difference between revenue and the cost function. So the break-even point or break-even analysis. The businesses want to know when they stop losing money and start making profit. This point is called the break-even point. The businesses want to know when they stop losing money and start making profit. So this point is called the break-even point. So that is, the break-even occurs when the revenue and the cost functions are equal. So break-even occurs when the revenue function equals to the cost function. Okay, then let's see the count example. The given example says the fixed cost is 10,000, cost per unit 20, cost per sell-in 50. Then the cost function would be C of x fixed cost plus 20 times x. Revenue function S of R of x 50x. Right? Then to get the break-even point, set them equal. C of x equals R of x solve for x, it should be 3, 3, 3, 3, 3. So the company must sell about 334 units before it starts making a profit. So always please make sure to round it up to the nearest whole number, because we are not going to make the half away of the units. We are not going to sell the half unit. So the company must sell 334, not 333.33, right? So always round it up to the nearest whole number. But if you have the whole number, then remain with that whole number. If not, round it up to the nearest whole number. The company must sell about 334 units before it starts making a profit. Here, X value means the break-even quantity, the quantity the company must sell to get start the profit, the break-even quantity. Break-even revenue, that means the company earning the money that company earn by selling the break-even quantity. R of 334 break-even quantity and break-even revenue. $16,700. Substitute the break-even quantity into the revenue function to get the break-even revenue. Okay, here you can see the one more exercise. So please pause the video and try it yourself. Okay, you can check your answers. The break-even quantity should be 2000 units and the break-even revenue should be 16,000 for the given example. Okay, then let's move forward. The another important application is finding the equilibrium point in economics. The equilibrium point is where the supply equals the demand. So that means we wanted to get the demand equation and the supply equation, solve that two equations simultaneously. To get the meaningful solution, the quantity demand should be greater than 0, the positive value, and the price also positive. So let's see the example. The equilibrium analysis, given demand function P equals 100 minus 2x. Supply equation P equals 20 plus 3x. Then set them equal 100 minus 2x equals 20 plus 3x. Then solve for x. X equals 16. Then find the price substituting that x equals 16 into the either of the equation. $68. The equilibrium point x naught 16, the quantity demanded, and the price 68. This should be the equilibrium point. And again, you have the exercise. Please pause the video and try this problem yourself. Okay. So let's summarize the today's lesson. Today we learned how to find the intersection of two lines, how solving system of equations gives us a common point, and how intersection points are used in businesses to find the break-even point where they start making their profit, and how economists use intersection to determine market equilibrium. Okay, in our next section, we will continue applying linear models to solve practical problems. Thank you for watching.